122 years ago, Kitty Hawk made its first flight. It was only 8 or 10 feet above the ground and only made it 120 feet, but all the same, it was the birth of aviation. A day ago, as I record this, NASA's X-59 plane broke the sound barrier at 700 plus miles an hour and 43,000 feet, all while producing minimal sonic booms, opening the doors to future faster-than-sound commercial aviation. So how did we get here? Examples like this have always made aviation a visible yardstick for just how far technology has come in the last century. But beyond providing impressive contrast, it can be difficult to understand what the dramatic technological shift in fields like aviation can mean for how humanity has changed and how it will continue to do so. One framework that can help to answer questions like this is an analysis of changes in aviation through humanist, transhumanist, and finally post-humanist viewpoint. The attitude of humanism is reflected most in the early days of aviation, and it is described by science and technology scholar, author, and professor Catherine Hales as a view where the human, quote, is traditionally assumed to be a coherent, rational self, the right of whose freedom of choice and will is the foundation of their governance. She goes on to talk about how consciousness, rather than embodiment, is regarded as the seat of human identity, meaning that rather than any sort of inherent physical qualities, what is most important to someone being a human is their consciousness and ability to make decisions for themselves, or in the case of the Wright brothers, our ability to fly an airplane according to the pilot's will directly. The significance of what the Wright brothers had achieved was that their flight was both powered and sustained. These are necessary for the complete control of a machine's movement in the air according to the pilot's will. In short, these are the capabilities for flight needed to be humanist. It is not a coincidence that this is the first time that an airship had been considered to be an airplane, which demonstrates that humanist control was built into the very definition of aviation from the start. In order to further the human aspects of flight, the Wright brothers wanted to make a control system that was more intuitive, lessening the barriers between the pilot's mind and the behavior of the plane. The Wright brothers created a positive control system that enabled, indeed required, the pilot to exercise absolute command over the control of the machine in every axis at every moment. Others had rejected this goal because they feared that the pilots would be overwhelmed by the difficulty of controlling a machine moving in 3 dimensions, but the Wright brothers proved that this was entirely possible. Once again, cementing humanist capabilities is one of the most important parts of the birth of aviation. Shortly after, aerospace engineers began moving towards flight capabilities that would require a different relationship between the pilot and the machine. If complex aerobatic and even supersonic flight was ever to be achieved, the humanist master and subject relationship would have to change. The human and the machine would have to work together in a thoroughly transhuman effort. Nick Bostrom, a philosophy and technology researcher at the University of Oxford, has a working definition for transhumanism in this case. He talks about transhumanism promoting an interdisciplinary approach to understanding and evaluating the opportunities for enhancing the human condition and the human organism opened up by the advancement of technology. In this case, the human condition was advanced by seemingly shrinking the world and breaking down travel and time barriers through faster and more complex flight, only achievable through transhuman aviation systems. Transhumanism started coming into the aviation space almost immediately after the Wright brothers' first flight. There were many innovations, but all of them had the common goal of reducing pilot workload and making sure that more complex and faster flight was possible. The first autopilot systems were used in 1912 and demonstrated in 1914, and although they were completely mechanical, relying on gyroscopes and mechanical actuators to make sure that there was positive stability control so that the pilot could take their hands off of the yoke and the plane would stay in a straight and level attitude. They were still very functional for reducing pilot workload. This trend continued through the 1930s with the introduction of radio navigation and VOR systems. These allowed planes to navigate more complex routes with more checkpoints over longer distances, instead of requiring the pilot to constantly be checking a magnetic compass. The 1960s saw further leaps in transhumanist ideas in aviation. Airliners gained multi-mode autopilots and instrument landing assistance, which enabled more automated course following and zero visibility approach and landing procedures, once again guided by computers. The automated navigation and landing systems in the mid-20th century were not the only transhumanist developments in aviation. In the 1960s, joint efforts between NASA and the United States Air Force brought about fly-by-wire systems. Previously, All control inputs into the aircraft's flaps, rudders, and ailerons were done directly by mechanical linkages from the pilot's hands into the yoke into the plane's systems. This was changed with fly-by-wire, which instead allowed the pilot to make a control input. This was sent electronically to a computer, and then the computer sent a signal to control the plane's surfaces. This was a radical departure from the direct humanist control systems of the early aviation age. This allowed the computer to prevent unsafe maneuvers and gave it a say in how the aircraft was controlled. This also allowed inputs and corrections to be made faster than a person could react, allowing for more difficult maneuvers to be executed reliably. One of the most famous and dramatic examples of the capabilities of fly-by-wire systems was a minimum radius turn done on an F-16 fighter jet, one of the first military platforms to incorporate fly-by-wire. This particular maneuver puts tremendous stress on the plane's systems and requires constant adjustment faster than a human could react. So what happens is the human makes the decision to execute this minimum radius turn, the direction it should go in, and controls the overall arc of the plane, while the computer goes in and manages the fine adjustments of all the control systems simultaneously in order to make that maneuver dictated by the pilot happen. This is a prime example of transhumanist aviation in action. The human and the computer are working together. The computer takes workload off the person, and together they accomplish a maneuver that would have been impossible with strictly humanist control. Despite the fact that the transition into the transhuman periods of aviation saw a consistent increase in automation and machine involvement and the decrease of the human direct control of the aircraft, there is nuance within the transhumanist eras of mid to late 20th century aviation. Within the general transhumanist framework of the human pilot and the automated systems of the plane working together, different emphases emerged with different types of flying during this time. The rugged individualism of the pilots established during the humanist era was retained in many ways, making a human-focused transhuman sub-designation. But within this same overall transhumanist period, the human-focused sub-designation rapidly gave way to more machine-focused transhuman flight, especially for wartime applications. One of the best demonstrations of the retainment of humanist attitudes of individualism within this transhuman period of mid to late 20th century aviation is the movie Top Gun. This film fairly accurately presents the attitude of the time that the public and the Air Force held towards their fighter pilots. They are seen as heroes, each with their own larger-than-life personality, and despite the fact that their planes are thoroughly transhuman technology, they are shown as being in total control of them, with a jet only being necessary to let them fly faster and higher than they could by themselves. Despite the fact that these features are very present in their F-14 Tomcat fighters, there is no mention of the avionics and computer systems working in the backgrounds to allow such fantastic maneuvers and flight patterns to be pulled off. Perhaps the best example of the humanist slant present during this period of transhumanist technology is the main character of the film himself. His escapades and stunts within the airplane are legendary, and his status as a symbol for humanism within a transhumanist world of the film is cemented by his character's name, Maverick. It's also worth noting that even within this popular film, the transition away from humanism within aviation is apparent. Not only does his character arc involve him learning to fly within the parameters set forth by the machines and the regulations of the United States military, but the very planes themselves that are used in the original 1980s movie are the last run of fighter jets that the United States military used that were not fly-by-wire and allowed direct control inputs from the pilots to go to the control surfaces. The Top Gun movie of the 1980s was a celebration of the last generation of fighter jets to allow humanist direct control inputs. After that, flying changed forever with the introduction of the fifth generation fighters. The involvement of computer decisions in aviation did not stop with the introduction of fly-by-wire systems. During the 1990s, the American military complex was developing an entirely new generation of fighter jets, with a key focus being a more heavily automated system. These fifth-generation fighters would further advance the machine's role in aerial combat and even pave the way to post-human flying. The introduction of the first fifth-generation fighter jet, the F-22 Raptor in 1997, marked the transition from the humanist emphasis of the transhuman flying overall period fully into the machine emphasis of the transhuman overall period. The fifth-generation fighter jets entirely changed what flying was. They have new suites of sensors that can automatically track multiple targets at once and allow them to be hit from beyond visual range. There is greater automation in aerial maneuvers with thrust vectoring technology, which changes the shape of the exhaust structures around the engine to vary the direction the thrust is going. These are all systems that the pilot does not directly control, but they change according to what maneuvers the pilot wants to do. All of these items make a combat system where the plane's onboard technology does most of the tasks, expanding well beyond what human senses are capable of, while the human operator's role is more removed and more oversight related. As highlighted before, aviation is often a visible yardstick for highlighting just how much technology has advanced in the 20th century, juxtaposing the humanist dogfighting of World War II and Vietnam with the automated beyond visual range missile capabilities of fifth-generation fighters is a clear demonstration of the differences between the early humanist days and the machine-focused periods of transhumanist flight. With the path being set for higher levels of automation in aviation by these fifth-generation fighter jets and more advanced avionics, there are multiple possible post-human futures in aviation. In Hales's book, How We Became Post-Human, a functional definition is presented that is particularly applicable to aviation. In it, she talks about post-human does not really mean the end of humanity. It signals instead the end of a certain conception of the human, of those who conceptualized themselves as autonomous beings, exercising their will through individual agency and choice. The idea of the transition into the post-human being marked by the ending of individual agency and choice is supported by some of the patterns we see of drones being used in current military conflicts. The traditional idea of military drones is one that is actually a transhumanist system that has a pilot who is grounded, but nonetheless a human, controlling the actions of a machine. The General Atomics MQ-9 Reaper is an example of this. However, recently the post-human has become more prominently with the usage of drones that have capabilities to make decisions on their own. These are being seen more and more in the Russia and Ukraine conflict. There have also recently been multiple human and AI dogfights tested showing the capability of machines to make decisions for themselves instead of people. The world of commercial flight is advancing into the post-human era as well, with modern avionics allowing planes to traverse commercial routes completely autonomously from takeoff to landing. However, just as with the transhumanist period of aviation, there is nuance in the post-human, and the elimination of human pilots is anything but inevitable. Professor Lenoir at the Science and Technology Studies Department of UC Davis suggests that one of the elements of a post-human future is the idea that it does not matter what is human and what is not, as the designation becomes almost irrelevant as technology advances sufficiently to replicate human capabilities. It is possible to see a future in commercial aviation where this is the case, especially since passengers are frequently walled off from the cockpit and prevented from ever seeing the pilots. The idea comes up that if planes are capable of flying themselves through their commercial routes, will it even matter if there's a human pilot in the cockpit at all? But recent research goes against this idea. While estimates vary from 65 to 80%, the number is always quite substantial of people that would refuse to get on a plane that they knew did not have a human pilot in it. While it can be difficult to make sense of just how far aviation technology has come in the last century, the concepts of humanism, transhumanism, and posthumanism can provide a useful and accurate general structure to the changes. And while, from a distance, the progression from the Wright brothers to fifth-generation fighter jets autonomously shooting down targets over the horizon can seem like a linear takeover by machines, there is nuance. There have always been those that valued humanist control, and vintage stick and rudder airplanes with no computers at all are some of the most popular in recreational flying today. Even in commercial flight, public opinion heavily slants towards needing a qualified human controller at the yoke and is unlikely to change. For the foreseeable future, there will be human hands directing aircraft's movements, continuing the legacy set out by Wilbur and Orville Wright in 1903. To put it in the immortal words of Mr. Tom Cruise in the movie Top Gun Maverick, when he was told by the higher-ups that his kind of rugged individual pilotage was headed for extinction in the future of drones, he said, "Maybe so, sir, but not today."